C section of the 2026 paper. The total number of visitors to a wildlife park each day over a 3-week period is shown in a matrix V below. Please look carefully at the places I've highlighted because those convey a lot of information to us as the question goes on. So the important thing is to see what the rows are trying to tell us and what the columns are trying to tell us. Now, the weeks are 3 weeks, which are the rows, and each day is each of the columns. Write down the order of the matrix V in the boxes below. So we know that there are 3 rows and there are 7 columns, and the order is 3 by 7. Matrix S and V have been multiplied to form the product SV. This matrix SV is a row matrix. Okay, so it has a single row showing the total number of visitors on each day over the 3 weeks. The total number of visitors each day. So basically what they're trying to tell you is that the multiplication of these two gives each of these is a total for each day. Okay, so now let's go back. Write the S below. So what it's telling you is multiplying S into this V helps you sum to find the total, okay, number on each day. That means what I'm doing is I'm finding a total for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And as you can see, if I put this in a matrix, I would get what we call a row matrix, as they have mentioned here. Okay, now in order to find the total of either a row or column, we use what we call a summing matrix. Now, a summing matrix is used to get the total for each day. Now, a summing matrix consists of ones, okay? Now, depending upon how many numbers you're trying to add, you pre-multiply it by that many ones. So, logically speaking, if I was to get the total here, I would have multiplied 759 times 1 plus 885 times 1 plus 812 times 1. And the addition of those answers would be this total for Monday. And how would you do that? So these ones come from this particular row matrix. Now, another hint is how many answers do I want? So if you look at this particular matrix that I showed you is the total matrix for each day. The answer that we will get over here is a 1 by 7 matrix. Okay, 1 row and 7 elements in them, which is 7 columns. Now, if that is the case, you'll have to check and see. S has to be, now in order to get a 1 by 7 matrix, the 1 comes from the S and the 7 comes from V. So what is this column of S and row of V? That has to be equal. So we know currently that V is a 3 by 7 matrix. So S has to be a 1 by 3 matrix. And that gives you an indication that it should have 1 row and 3 columns, and they should consist of ones. Okay. Question 10. A merchandise stall sells soft animal toys in 3 sizes: Pocket Pal, Cuddle, and Jumbo. So we'll talk about them in terms of PCJ. The retail price in dollars is given by the matrix. So usually, because I'll be dealing with quite a few matrices, I write what that matrix represents next to it so that it's easy for me to go back and forth on it. Matrix Q below gives the number of each toy. So this is the number of each, sold on 2 different days, Saturday and Sunday. Explain why MQ is not defined. Now, M is of order 3 by 1, whereas Q is of order 3 by 2. The number of columns of M is not equal to the number of rows of Q, and therefore it's not defined. Now, if you were to put it in a way that actually will get the perfect score, you should write, I usually write order of M is 3 by 1 and order of Q is 3 by 2 as the number, okay, of columns of M, which is 1, is not equal to the number of rows of Q, which is 3. MQ is not defined. Now, that definitely will never lose a mark. What some students do is they miss these words, okay, and they say as the columns of M is not equal to the rows of Q, Now, it's not the columns and the rows that should be equal. It is the number of columns of M should be equal to the number of rows of Q. Okay. So, if possible, take this down somewhere where you can, if you're using a bound reference for your exam, that template should definitely help you. The manager of the merchandise stall completes a calculation to determine the total revenue in dollars from the toys sold on each of the 2 days. So, what he's doing is he's trying to add up and find out how much revenue he made on each of the 2 days using this particular equation. Now, Q transpose. So, if we look at Q, that is Q. Now, in order to do a Q transpose, you have to make the rows equal to make the rows the columns and the columns the rows. So, if it was a 3 by 2 matrix, Q transpose will be a 2 by 3 matrix. Okay, and so Q transpose is this matrix, and that's a 2 by 3 matrix where every row has become a column and every column has become a row. And so that Q transpose matrix multiplied by M, which is your price matrix, okay, will, now if you look at what will it give you, but the process of multiplication is such that your first answer, now because this is a 2 by 3 and that's a 3 by 1, you will get a 2 by 1 answer, okay. Now if that was to be a 2 by 1 answer, the only quantities that are two quantities in this question are Saturday and Sunday. Okay, so Saturday and Sunday. And what do these numbers actually represent? These numbers actually represent the total revenue made by selling these toys on 2 different days. Okay, so 193 multiplies by 850 plus 176 by 18 and plus 284 by 2890, and that gives you this revenue on Saturday for selling these 3 different kinds of toys, and this other value is for Sunday. Okay, so if they asked you what do these answers represent, you have to actually say, one, that it is the total revenue got by selling these 3 toys on Saturday and Sunday. So you have to be extremely explicit with your answer. You'll have to talk about the rows and columns and connect it to the elements in the matrix. Now, new customers receive a 12% discount when purchasing from the stall. Matrix M can be multiplied by a scalar P to determine the discounted price. So we know that if it's 12% discount, that means the new item, the new price is 88% of the old, because 100 minus 12 is 88 of the old price. This is just a concept relating to percentages, which is learnt in the lower classes. Okay, and so 88% is nothing but 0.88. So if you multiply 0.88 into the original price matrix M, you should get the new price. Each of those values are discounted or lowered by, decreased by 12%. Question 11 is a Leslie matrix question. The wildlife park is studying the population of female numbats in a national park for a 10-year period for the first, second, and third year. Now, as Leslie matrix for the population is given below. So you know a Leslie population. The first row is actually the birth rate, and the next 2 rows talk about the survival rates. So what does this talk about? That is, the relationship is between the years, the first year, second year, third year, and the rows also first year, second year, third year. And if you were to represent that in a Leslie diagram, you will represent it the way it's shown over here. You'll write 1, 2, 3 years, which are the time spans, or in other words, age groups, and the survival rates are written because the first to the second year, the survival rate is 35%. So this is the survival, and each of these is the birth rates. okay, arrows. And so 35% survive from the first to the second year, which is this value. And then from the second to the third year, 22%, and which is that value. Whereas if you look at the birth rates, there are no birth rates, there's no offsprings when they're 1 year old, but from when in their second year, they give birth to 2. So the offspring is from 2 and you bring the arrow to 1, and because that's your initial birth, okay, position. And then in the third year you give birth to 1, and that also goes back to this group, which is your initial when you were just born, okay. So any babies go back to group 1. So interpret each of these elements in the first row matrix L. So clearly the 0 means that there were 0 offsprings in the first year of life. Try and connect it to the words in the question as much as possible, okay. 2 offsprings in the second year of life and 1 offspring in the third year of life. So what percentage of female numbats in their first year are expected to survive to the third year? So in order to get from the first year to the third year, you have to also go to the second year. So from the first year to the second year, okay, so we are looking at first year to the second year, okay, 35% survive. And we can see that on the Leslie diagram as well. Now, so from the second year to the third year, okay, so from the second year to the third year, 22% survive. 22% of this 35% in the previous year. So when you multiply the 2, 0.22 times 0.7, 0.35 is 0.077. So that's a question that's a little different from the previous years. And then one of the criteria for a species to be classified as threatened is a significant population decline over time. The level of threat to a species can be described as critically endangered, vulnerable, or least concern. Now, this is determined by the decline as a percentage over a 10-year period, as shown in the table. So, if the population decline is greater than 90%, it's critically endangered, and 70 to 90% is endangered. 50% greater than 50 and less than 70 is vulnerable, and less than 50% is least concern. So we've got to see the decline over a 10-year period. So matrix S0 represents the initial population, which is given to you here in the question, and showing relevant calculations determine the level of threat faced over a 10-year period at the start of 2032. So we know that this is at the start of 2022. So if we calculate over a 10-year period, okay, 2032 population, so we know we can just consider it like a normal transition matrix where we can raise it to the power of 10 and the initial state matrix, and that will give you this matrix, okay. Now, so over a 10-year period. Now the initial population, now because we're talking about a decline, we have to know what the initial total population was 159. And the new population at the end of 2032 works out to be 46. Okay, so I've rounded off all these values approximately to 1 decimal place to maintain some level of consistency. And so 46.2 approximately 46. So the reduction or the decline is the initial population 159 minus 46, and that gives you 113. So they're talking about what is the percentage of reduction, because only then will you be able to compare it to this table. And so the reduction percent is the reduction, the decline over what it was initially times 100, which is 71%. So determine the level of threat faced. So if it is 71%, I suppose you can look at it as endangered. And so that would be the answer. The next question, question 12, the wildlife park wishes to track sugar glider movements across 3 zones, J, K, and L. Let A and B the state matrix for the number of sugar gliders expected to be at a region at the start of year n, and the matrix relation, recurrence relation shown to calculate the expected number in each region from year to year is given by this equation, where A is given, T is given, and B is given. How many sugar gliders are expected to be in the zone J at the start of 2023? So here, this one is 2025 given. So that's like going backwards, isn't it? So we know that A 2025, according to this equation, is a transition of A 2024 plus B. And so A 2024 will be equal to, let's say T of A 2024 is 2025 minus B, which gives you a matrix. And this is a concept, A 2024 is a T inverse of this matrix that you have got, not of, times actually. Now this is the concept AX is equal to B, X is equal to A inverse B, okay? So this is an application of that concept. And so in order to find year backwards, in order to find 2023, we have to do this particular calculation. And when we do that, we get A 2024 and we put it into the calculator exactly as I have written it, of course with substituted values for T, etc. And you get the values for A 2023, for A 2024. Now you go backwards and you know that this is the equation that holds, and you do the same calculation backwards. A 2023 is T inverse of A 2024 minus this addition and subtraction. This is a restocking and culling matrix, okay? And it gives me the answer, as you can see over here. So in the long and in zone J, so you know that J is your very first value, which is 1400, and you should be writing that as your answer. Okay, maybe you could do all this working at the bottom of the page and just write the answer there. In the long term, how many sugar gliders are expected in total? How many sugar gliders in total are expected to be in the wildlife park? Now, usually in a normal transition matrix, now what's a regular normal transition matrix? Where the columns all add to 1. And here we can see that it is the case. In a scenario like this, we can expect the initial total to be the same as the final total. Okay, so that means the initial total was 2200, the addition of these three values. And we can expect the final total. Also, the second thing we observe is what is restocked and what's culled. Okay, the minus values, they equal to 0 when added. Okay, and because of both these scenarios, we can say that the initial number will be equal to the final number in the long term. And so 2200 is your answer. So hopefully you have got some idea about how these questions are to be approached, and I'll see you again in another video. Bye.